Okay, here we are. This is section 1.3 video number 2, and it's asking us to do a strange thing. Actually, I remember doing this as a young student, and they had us do it by hand because, well, computers weren't invented back then. They were. They had old, big, giant processors. Anyway, you guys have got laptops. You can do stuff on your phone, etc. This is a problem. Let's see if I can get there. I've got to, oh, I forgot. I got to upload that. Just hang with me, send a copy to that guy and create a new note and import, and it's done. And then I can get to Notability. And where are we? Let's see, that one. Okay. Well, you got to see that whole process, didn't you? I'll leave it alone. That only took about 15 seconds or whatever. So I have to be able to draw on this, and so I'm drawing on this guy right now. In fact, I might not have had to have changed it, but this is we're ready to go. So this is from page 27, number 24, and they're saying, these guys are like problems 21 and 22, but what you're supposed to do is use a computer algebra system to plot and print what? A slope field for the given differential equation. Okay, if you wish and know how, you can check manually and blah, blah, blah. Okay, so I chose number 24. And what I did is, well, I'm not going to show you. I'm going to, you know, what I did, maybe I can show you. Hang on just a second. It'd actually be pretty cool to do that. So I will. I'm going to share a screen, and I'm not sure what's up there right now. Yeah, this one. All right, but what I did was I went to Slope Field Generator, and I clicked on Desmos. So I went to Desmos. Let me clear that. And I typed in, see this right here? I typed in, they have g of xy is equal to, I typed in this particular, our particular problem, okay? And it created this slope field for our function. So now I'm gonna go over, and what I did is I cut and pasted into a file that I just shared, and here it is again. So I am going to do that. Okay, cool. So that's what I did, all right? I took this guy's expression here, and I put it into that slope field generator, and it should be down here. I cut and pasted in, and there he is. You see him? There he is. So that's our guy. All right, that's the slope field generator. It says if you're a solution to that, if you're a function with that differential equation, and you go through a point somewhere, wherever it might be, the slope for your curve is exactly what we're showing you right there, okay? And if you could do that manually, it would be a real bummer. But anyway, what we're supposed to do in this assignment is go find this point here. Really, that means x is -2, y is 0. We're going to go find it right now, and I actually have it. I see I kept my little dot right there. I'm going to say that that's approximately -2, 0. In fact, that might not be. Let me erase that. I don't think that's correct. Let's do it right, Weber. So go -2. Yeah, this is -2, 0. This guy right there. So that I just plotted -2, 0, and I'm going to go back up, and they want us to estimate. Hey, think of us in the dark ages of differential equations. Take your slope field, go through the point that I want us to in our experiment or whatever, but I want to be able to predict what the function value is at 2 without actually finding the function. So I can use your slope field, I can guesstimate like an artist where the curve is using the slope field, and then I can maybe estimate what the function value is. Now, when we get into what they call Euler's method and Runge-Kutta, we actually do it analytically and crunch it with numbers and come close, but it's not, in other words, before we were able to build and find an ability, gather the information to be able to find solutions to differential equations, we could still pick around the edges and maybe estimate what the solutions are. So this is how you do it. We want y of 2, right? So this is 2, and I don't know where we're going to be, but we would follow, in my pictures, I'm not an artist, but I would guess that, okay, we must be cruising down this way, and I'm going to just kind of pick these guys and float up, and think that I'm doing pretty good, and I'm just cheating a little, and I'm going to continue upward. So the function, whatever it's doing, okay, it might be coming in like this and cruising up, and I'm not sure. But with that information, we're supposed to guesstimate. Oops, I shouldn't have done that. We're supposed to guesstimate y of 2. So if it keeps on cruising up, let's pretend it does that. Then what you can do is read across here and go, you know what? It looks like it might be going through 2. Okay, it might be. All right, by following the slope curves. As I went down here and as I went this way, I'm trying to rest my curve on the slopes of tangents to find that answer. And so I'm going to guess that y of 2 is equal to 2, and I'll send it to the lab and see if that makes sense. That's it. Every single one of those little, what do you call those things you sprinkle on a cupcake? These guys, these jimmies, I guess. Every one of those jimmies is really just a slope, a piece of a tangent line. So our curve has to kind of swing, and you can tell by just, you can start over here and go, oh my goodness, this guy's going to drop down, but then he's going to bounce back up, or whatever it might be, by following well, you can, Calc 3, we have vector fields too and things like that. So that's it for this video. It was a crazy one, but I hope that helps a little bit in understanding, because what this is you are dealing with primitive stuff. You're actually literally, without it, this was with a computer, but without one, you would plot all these guys and at least have an idea. So in other words, these come from the derivative level, as if we can't get to the actual function level, but we can at least follow it like a piece of spaghetti and estimate. That's very primitive. That's it. We'll see you in the next section.